Hi guys, this is Anmol Talwar and welcome back to another video with Talent Catalyst AI, where we strive to give you industry-specific artificial intelligence knowledge which will surely help you grow in your career ahead. With a work experience of over 7 years, I have handled projects related to natural language processing, artificial intelligence, machine learning, and generative AI across industries such as banking, pharmaceutical, financial, as well as marketing technology. So, let the learning begin. Topic for today's video is basic evaluation matrices with respect to machine learning. So today what we'll be going through is four basic machine learning matrices to judge if the model that we have trained is worth it or not. The first one is precision, second recall, third is accuracy, and the fourth one is a mixture of precision and recall, that is an F1 score. We'll use the same use case which we used earlier in our confusion matrix video for explaining that, that is a spam versus a non-spam email predictor. I'll strongly recommend to go through that confusion matrix video to understand what exactly is a confusion matrix better, which will help you understand the evaluation matrices even better. So the use case is simply whatever email that we get in our inbox, we just have a machine learning model to classify those emails as spam or a non-spam, a binary classification, classical binary classification problem. Okay. So just to recap, what we have over here is a confusion matrix where on the y-axis we have the actuals, and on the x-axis we have the predicted, that is what the model predicted. So just to go through this, 600 essentially over here is a true positive, saying that 600 emails were actually spam and the model also predicted them as spam. Then the diagonally opposite one is a true negative, saying that 9,000 emails were actually non-spam and the model also predicted them as non-spam. So this is the intersection. This is 9,000. Coming to false positives, this particular quadrant is a false positive wherein the email was actually non-spam. Hear this carefully, the email was actually non-spam, but the model predicted it as a positive class, that is a spam. Since it was wrongly classified as positive, it's called as a false positive. Then the diagonally opposite of it is a false negative, just the opposite of it, wherein actually the email was spam. It was a true positive class, a positive class spam, but the model wrongly classified it as non-spam, that is a negative class. Hence the name is false negative, right? Now coming to the evaluation matrices. Based on the similar concept of confusion matrices, we have these four evaluation matrices, namely precision, recall, accuracy, F1 score, and their respective formulas. No need to memorize these formulas. Let's look at them logically to understand better. Now let's try to comprehend each of these evaluation matrices effectively. Starting up with precision, the formula says that it's a ratio of true positive and a summation of true positive and false positive. So we have the true positives over here, the numerator, and the summation of true positive plus false positive over here. So we have these two quadrants summed up over as the denominator for precision. So precision, what it says is precision is essentially the ratio of true positive divided by the predicted truths. This is a star mark, predicted truths. Why? Because we have these two quadrants summed up in the predicted class. All the positives, that is the positives, the truths are the class of our interest. What this says is what is the quality of prediction the quality of prediction. Why? Because we are trying to check the ratio of the true positives with respect to the predicted truths, which gives us the quality of prediction, is what precision says. Relating this to our spam versus non-spam problem, this says that of all the predicted truths or all the predicted spam emails, spam was the class 1 for us, or the class of interest. Of all the predicted spam emails by the model, how many were actually spam is what precision means. Coming to recall, we'll map the numerator and denominator for recall over here. The numerator is true positive, this one, and the denominator is true positive plus false negative. This plus this. These two quadrants are being summed up over here. So what recall says is recall is a ratio of true positives divided by the the actual truths or the actual class of interest, because we have the summation with respect to the actual classes, actual positive classes. In other words, of the actual truths which we had with us, how many of them were actually predicted as true by the model? If we relate this to our spam versus non-spam example, of the actual spam emails, how many of them were predicted correctly by the model as spam? Both recall and precision have the same numerator, that is the class of our interest, that is true positive. The class of our interest which was correctly predicted is the numerator for both precision and recall, right? But the denominator is where they part ways, wherein precision has the denominator as predicted truths, whereas recall has the denominator as actual truths. This is the difference between precision and recall. Coming to the third measure, that is accuracy. Accuracy is a ratio of summation of true positive plus true negative and the whole population. So we'll map it over here. True positive, true negative in the numerator, the summation of these, the diagonal ones, and divided by the whole population. Why is it called accuracy? Because true positive and true negative are the correctly predicted classes. So true positive means if the actual was also true, the actual was also positive and the predicted class is also positive. The negative means true negative means the actual class was also negative and the predicted class was also negative. That means the numerator says that both classes have been correctly, both the classes, positive and negative class, have been correctly or accurately predicted by the model. Divided by the whole population gives us the accuracy. Whereas in precision and recall in the numerator, we were only focusing on the positive class, the accuracy of the positive class. But in accuracy, we are focusing on the accuracy or correctness of both the positive and the negative class. Now, what is F1 score? F1 score essentially is a combination of both precision and recall. It's a harmonic mean of both precision and recall. This formula is a harmonic mean formula. Why do we use F1 score? Essentially is since precision and recall are negatively correlated, which we'll discuss deeply in another video, but to give you a sense, precision and recall are negatively correlated. If the precision goes high, the recall will go down. If the precision goes up, the recall will go down. This is what is meant by negatively correlated. So since these two cannot go hand in hand, we have a separate score, which is essentially, let's say, an averaged out score of both precision and recall to give you a sense if both of these matrices are performing up to the mark or not, is what is meant by F1 score in a easy, understandable way. Now let's try to assess all the things that we have learned using the use case that we had in our hand, that is spam versus non-spam, spam being our positive class or the one class or the class of interest, and non-NS, that is the negative class or the zero class, right? In the confusion matrix, we have this as true positive, this as true negative, this as false positive, this as false negative. Now precision is essentially also called as specificity. It measures the proportion of correctly identified spam emails among all the emails predicted as spam. Among all the emails, 600 plus 100, that is 700, all the emails predicted as spam, which of these emails were correctly identified as spam emails? Correctly identified as spam emails is true positive. 600 divided by how many were predicted as spam? 600 plus 100. This particular line, right? Now coming to recall. Recall, also called as sensitivity, measures the proportion of all the correctly identified spam emails till here, both the definitions remain the same. Correct proportion of correctly identified spam email among all the actual spam emails. The actual spam emails is this line, this particular line, 600 plus 300, that is 900, is the actual spam emails. Of those which were correctly identified as spam, that is the true positive, that is 600, that is our numerator, is the recall, the percentage we get it as 66.67%. Coming to the third one, that is accuracy. Accuracy essentially is, irrespective of the class, the model has correctly identified both positive and negative. The summation of those, that is true positive plus true negative, 9,000 plus 600, that is 9,600, divided by all the classes. That is, in the numerator, we have all the accurate or correctly predicted values, irrespective of the class, positive or negative. In the numerator, we have everything. Gives us 96% of accuracy. F1 score, in between, trying to merge both the precision and recall, trying to get us a number to sense if both of them are performing good at a certain threshold. We have the F1 score, that is the harmonic mean of precision and recall. We have it at 74.99%. So just to give you a sense of F1 score again, we have a precision at 85, right? And the recall at 66. Recall is low, precision is high. So the average, the harmonic mean number representing both precision and recall, we have it at 74.99%, which says that there it averages out both precision and recall, since precision and recall are negatively correlated to each other. Now coming to a practical scenario wherein we need not go through the whole cycle of mathematics to get those precision or recall or accuracy or F1 score or any evaluation metrics for that matter, we'll have a practical example of Python notebook where we can do this just on a click of button using Sklearn libraries. Let's say we have an actual and predicted list. The predicted, which we got it from the model, which we saw in our spam versus non-spam use case. Let's try to print the length of the actual and predicted lists. Essentially, actual and predicted have both zeros and one. Just to give you a sense of how it looks, is this. The actual has zeros and ones, and similarly, predicted has zeros and ones. One meaning it is a spam, zero meaning it's not a spam. Just hiding it for visual representability. So we have 10,000. Just to reconcile it, if you see it over here, if we sum 600 and 300, we get it as 900, right? Now, if we sum 100 and 9,000, we get 9,100. Summing up all of those, 9,100 and 900, we get 10,000. That is essentially reconciling what we have from the model, the actual and the predicted 10,000 versus what we did in theoretically there in the slides. Now, now that we have the actual and predicted, we'll import the confusion matrix and classification report from the sklearn library and try to print the confusion matrix. Confusion matrix essentially over here is 9,100, 300, and 600. It'll match with our confusion matrix. Just over here, the axes are flipped, but it essentially is the same: 9,100, 300, and 600. Seeing it over here, 9,100, 300, and 600. It matches, right? Now let's match all the evaluation matrices that we got out from this particular confusion matrix. We'll print the classification report wherein we'll just pass the actual and predicted and the classes that we had, spam and non-spam. Since the class of interest, that is class 1, was our spam, we wanted to predict the spam emails. We'll check the scores for this. The spam precision that we got 86, wherein we got over here as 85.71, rounding 85.71 we'll get as 86. That is correct. Recall as 67 over here. Here we got it as 66.67. Again, rounding of 66.67, it is 67. That's correct. Accuracy over here is 96%. Accuracy over here essentially matches again. That is 96%. The F1 score, the harmonic mean of precision and recall, we got it as 74.99%. Rounding it off, we'll get it as 75, and essentially it matches with the 75 number over here. So this is how we need not go through all the mathematical ratios, summing up and dividing. We can just use the sklearn classification report and confusion matrix to get these things easily. Please do not forget to like the video and subscribe to the channel for more such informative videos related to artificial intelligence. Thank you.